In this video the following concepts are studied. The derivation operation. Calculate instantaneous velocity by using derivation. Average speeds theorem. As we said in the previous part, the derivative method is needed to calculate the instantaneous velocity. A separate math course is required to master this topic. But we will also pay attention to the mathematical aspect of each problem as needed. Tip 4. If we have a polynomial, we use the following method to calculate its derivative. Note that the power of x, multiplied by the coefficient behind x, and it is reduced by 1 unit. For example, Tip 5, to calculate the derivative of a fixed number, or a linear function, we use the following two rules. It simplifies these two tasks. However, it is obtained from the general method we have mentioned. First, the derivative of the fixed number is 0. Second, the derivative of the linear function is equal to the coefficient of the variable. Tip 6. To calculate the instantaneous velocity, you must calculate derivative of position equation with respect to time. Then replace time in the derivative equation. Now back to the previous example.
Example 3. In the previous example, calculate the velocity of a moving object at moment 2. Recall that the place equation was as follows. First we calculate the derivative of the equation. Now we put the number 2 in the equation, it becomes 11 meter per second. We can calculate the position of car at this moment. We replace the number 2 in the equation of position. Pay attention to the calculations. The number 15 is obtained. Meaning that at moment 2, the car passes at a position of 15 meters from the origin, and at a speed of 11 meters per second. You can see by having the equation of position, we can get a lot of information. 1. By substituting an arbitrary number, instead of t, the location of the moving object can be calculated at any time. 2. Calculate the average velocity at any time interval using the following formula. 3. With the help of derivative, the velocity can be calculated at any moment.
Did you notice that the answers in examples 2 and 3 are the same? There is an important point here. Tip 7. If the equation of motion of a moving object is parabolic, that is the power of t is equal to 2, then the average velocity between the two desired moments t1 and t2, is equal to the velocity at the mean moment t1 and t2. Note that if the equation is parabolic, the object moves at a constant acceleration. This discussion is very important. We will look at it after the topic of constant velocity. Example 4. The equation of motion of a moving object which moves in a straight line is as follows. The velocity of this object at moment 3 is equal to 15 meters per second, and at moment 19 is equal to 13 meters per second. At what moment the velocity of the object is equal to the average velocity of the whole? What is the velocity of the object at this moment? Pay attention. It is very time-consuming if we want to solve the problem in the usual way. So we use point 7. The average times are equal to 11 seconds. The average velocity is equal to 14 meters per second. So at 11 seconds, the instantaneous velocity of the object is equal to the average velocity. That is equal to 14 meters per second. You may be wondering what the benefit of this is. The answer is in constant acceleration. For example, free fall, which is an important motion, and it is a motion with constant acceleration, that must be examined later.